Yes. So we were discussing about solder ball, right? So for the soldering of this BGA components, we need a solder ball, right? So guys, there are two types of, see, we're discussing about this BGA component. Okay. BGA means ball grid array. What is this meaning? Ball grid array. Ball array. Okay, means pins will be there. It will be in grid form like a array wise. If you see this, Menka. Okay, Menka, given the permission. Guys, if you see this is the BGA components. Okay. Pins will be there inside the body. The real example of this BGA component is computers, laptop, processors. Okay. Mobile chips, RAM. Okay. This all comes for the BGA. How it will be? I'll show you. See this. This is a RAM, right? See this. This all is a BGA component. Now see this. This all is BGA components. This all is BGA components. Okay. See this. This all the components you see on the PCB. This all is BGA component. Right? Guys, is that clear to all? Hello?
Yes,
Yes,
sir.
sir. Yes, sir.
And see this. Okay. This all is a BGA components only. Right? So this I'm going to illustrate. Okay. So balls will be there. That will be placed in like an array and it will be melted by some other heating process and going to solder with the our PCB. Okay, like our RAM, I told you RAM, processors, this all is the BGA components. Why it will be BGA components? The thing is, it is having a large number of pin counts. Okay, that can't be managed, can't be routed if you give QFP package, QFN package. So that can't be managed. Correct? No. So to reduce these bigger components, to reduce these signals in bigger manner or in big form, the developers and the manufacturers, they have invented the BGA packages. Okay, you see this in BGA packages, you will not get a routing spaces, you will not get the track spaces, but so many tricks are there, so many steps are there, so many procedures are there. Through this dense pins itself, you can able to route that. Okay, that will learn in the advanced class. Okay, so I think you will be going to design the BGA footprints also. That concept, it is having a very big concept, many more concept to understand and learn this BGA footprint creations. And guys, this is the last class for the footprint. Okay, next we are not going to discuss anything about the footprint because I have taught basic to basic, and the advanced one is our BGA. And BGA was the advanced, and our shape symbol means customized shape pads stack is also was in advanced. So this is our last class because we have spent more than 20 hours for the BGA means for the footprints, right? If you are going beyond that, our things will be again late. Okay. So here BGA. So BGA is having so many more concepts. So some advanced concepts I'm going to discuss. Okay. So if you see here, guys, we need, suppose this is the BGA, this is the pad stacks organized in a grid manner, means horizontal and vertical manner. Okay. And If you see this is a soldering ball. Soldering ball is coming over it here. Actually, here you can see only bottom view. Cross section view I will see. Okay, if you see this cross section view, this is our PCB. Guys, this is our what? PCB. This is our component, BJ component. This is a soldering ball, right? So if you see, first our component, then soldering ball, and then PCB. Okay. So if you see this soldering process, after melting of this solder ball, the pad will be covering only this. Correct? So guys, if you see this here, this area, if it comes flat, so this can touch this pad and this pad also, right? Pankaj, getting my points?
Sir, yes, there has to be like enough spacing between.
No, that's right. No, you will not get a space. Some things are there. I am just going to explain. Right? If you see here, the pad is lesser than the ball size. Right? So guys, there's some concept comes here in the BGA. Collapse pad stacks. Collapse pad.
Actually, just one question I want to ask.
Ah,
So, you are saying that there is a ball actually between the pad uh, or and the component, but
ha.
maybe my understanding was wrong. I was thinking that this ball is already a part of the component. Whatever
No,
you
no,
are
no, no, no,
melting
no,
the
no,
solder ball.
no, 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 no.
Okay, 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 got it.
This ball is not part of the component. This ball here is placing on the PCB with the help of BGA stencil. Okay.
Okay, okay,
This ball is placing here with the help of BGA stencil. Means if you see this, so here one stencil will come. Okay. So if I show here, see this. To for the soldering of the BGA components, all kind of this stencil comes for the BGA. See here. This all is the different BGA style stencils. You see this. Okay. And you see this. This is coming just to place the ball on the component and it will melt and then we will remove this BGA, this stencil. If you see this all is the BGA stencil only. Okay. To just place the ball over the PCB, right?
correct.
Okay. So I'll tell you the process. Understand this
Yeah,
concept.
yeah, sir,
Okay.
got it now.
So to attach these solder balls on the PCB, we need this kind of stencil that is called BGA stencil. Okay. And what kind of BGA you are using? You have to purchase the extra stencil to place only because this is a separate procedure. The BGA placement, BGA assembly is the separate procedure for the means it can't be done in reflow, it can't be done in wave. So after doing all the things, you have to do the BGA placements, BGA assemblies. Okay. So if you see here, what I was talking is, see, BGA balls will be bigger than the or pad stacks, right? So there's something called collapse pad stacks. So suppose this pad stacks, the dia they have given, the circular dia is suppose they have given 1 mm, 1 mm, right? So there is two parts is coming in the picture, BGA pad stacks. Let me clear here one. BGA pad stack. Two types of it is. It is collapsed pad stack. Another one is non collapsed. Okay, collapsed and non-collapsed. So collapsed rule is, if you find a data set, they will tell you it is a collapsed. Collapsed means, suppose this is given 1 mm. So what you have to do in collapsed option, they will mention in the data set you have to do collapsed or non-collapsed. So for collapsed, what you have to give here is the given pad dia, given pad dia minus 20%. Okay. For collapsed rule is given pad dia minus 20%. Or you can say here 80% dia of given pad size. Okay, so they have given here 1 mm pad size. So 80% means how much? 0.8 mm only. 0.8 mm pad size will be for non collapsed pad stack. Guys, clear? Collapse, you understood? If they given 2 mm, then your pad size will be 1.6 mm. Right? 20% you have to minus. Okay? Why 20% you have to minus? Because your copper area is this. Guys, just understand here one more concept. Your copper area is this. Okay? Ball area will be like this. This can be bigger. But if you see this, by the concept and theory, if you go, the ball, this is our pad. This is ball. Ball. Why collapse is, after melting of the ball, means once it will melt to solder that, it will not going to melt full. It will be some sticky type, top and bottom. Center will be hard and top and bottom is going to melt to assemble the component. So after melting of the ball, this ball is covering only 80% of the our copper pad of the PCB. Guys, can you see this? This ball is covering only 80% of the area of the our pad stack. How? Here you can see the ball is touching 60%. Ball is touching, as of now in this case, if you see here, ball is touching only 60%. This much area is touching for the our copper pad. Only as of now, only this much part is touching. 60% only is touching. After melting, it will become 80% here. Come to the edge, 80%. Okay. So that is called collapse pad. We have to, after melting, it is going to cover only 80% area of the our pad stack. Okay. So we are going to give here 80%. Correct now? Guys, clear? This point collapsed? Collapsed, understood, guys? Any doubt you have?
Yes,
Okay, non-collapsed means same pad you give, but as solder masking you have to give as the same as the pad size. Okay, solder pad will be, that is non-masked, that will be the as same as the RPC. What is the RPC? PMOC as the SMOC. Okay, guys, is that clear?
yes, sir.
So I have here given some BGA components also. You might have got that. This is a BJ component. Okay, see here, BJ component. Okay, see this. Here, suppose how much they have given collapse or non-collapse, they have mentioned. Here, dia anything given here, 0.4 mm. Dia B, NX. Anywhere they have given NX. NX are not given. Wait, some other footprints. Not given. This is the guys. So I mean to say, if they want collapsed or non-collapsed pad stacks, they will mention in the data sheet. Not data sheet, actually, this will be other part number itself. Okay, which part number they want to use as per your company, as per your hardware team, R&D team, they will tell. So that part number will be having either collapsed pad stacks or non-collapsed pad stacks. Non-collapsed pad stacks, you have to give solder mask, paste mask, and pad stack. RPC same. Okay, non-collapsed pad stack, you have to subtract 20%. Means if they have given 1 mm, so only 0.8 mm you are going to design the pad. Suppose they have given 2 mm, so only 1.6 mm you have to design the pad stack. Okay, understood? Now, so BGA will come like this. It will not come like a pin number, like 1 to 100. No, it will come in a matrix form, row and column form. If you see here, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, right? So 13, 14, 15, 16, 17, 18, 10. No, it will be not like that. It will not like 100, 144. No, it's not like that. It's having 144 pins, but directly we can't give 144 pins, right? Here you have to give, I'll tell. Matrix, guys, who have studied the matrix? Matrix and determinant in 12th class.
I think all of us.
So suppose here I want to draw the pins. So first of all, what I have to do? This will be, this pad will be, this pad name will be A1.
A1.
Okay. This pad will be A2. This will be something like A2. Okay. Like this also M1, M2, M3, L1, L2, L3. Okay. A1, A2, A3, A4 till to the L12. Right. So guys, I'm going to design this one BGA footprint. Okay. So here, file, new. Here, go to your footprint folder, browse here, BGA. Okay, 144. So in BGA 144, pins will be there. Then write here P. P means pitch. Okay, what is the pitch it is telling? 1 mm pitch. P 100. 100. Then again cross body size. What is the body size? If you see here body size, DE. What is the D and E? D is 12.8. E is also 12.8. So 12.8, 12.8, it is a square, right? So 128. Sorry, here underscore will come. 100 underscore 128 underscore, sorry, cross 128. Guys, how I am designing this name? Any idea? How I am deciding that name? If you have gone through this, this pad stack design. Pad stack. Here, if you go at the last page, I have given here naming conventions. See here. This naming convention will explain how to give the name. Okay. If you read this properly, you will come to know. Okay. So I have given the name of the part is BGA 144 means number of pins will be 144. P 100 means pitch 1 mm pitch. 120 1.28 by 12.8 or 12.8 is the our body size. Right. Same step. First you draw the pad stack. File, new. Here you choose SMD. Here, suppose we want which one, guys? What you want? Collapsed or non-collapsed?
Better we can go ahead with collapse.
Collapse. So 1 mm pad
Yes.
stack is there. So we need how much?
Yeah. 0.8.
So C 80 you can give. Simple. Choose here circle. Here you give diameter. Here millimeter. Diameter 0.8. Mask circle 0.8. No, collapse mean mask is there. No, so 1 mm mask will give. 1 mm paste mask 0.8. Okay. File. Save. Saved, guys. Now open this footprint. Your PCB editor. PCB editor. Go here, do some setups. Check this. Choose here millimeter. You can take here minus. Okay, leave as it is. Display origin 0.1, 0.1, 0.1, 0.1. Apply. Okay. Okay. Guys, so here if you see, our pad is there and we have a huge number of pins. We have a huge number of pins, right? So in this case, for time being, we are going to alter our grids. Here 1 mm gap is there, 1 mm pitch, vertical also and horizontal also, right? So in this case, a special case, we are going to alter some our what? Grid. Go setups, alter your grid, give here 1 mm, 1 mm. Okay. Apply. Okay. Okay. See this. From here to here become 1 mm. Right? Call your pads. Go to call pad. Take. What is the name? C80. C80 came here. Okay. Now, X quantity how much need, guys?
12.
Just wait. Hold on. Bottom view. This bottom view. Right? But what I told you, we have to create always footprints on which view?
Top view.
Top view. So this is the top view. Right? So this is the bottom view. Just mirror of it. So your pin number will come here on top. Right? So A will become like this. A1, A2, A3, something like that. Right? Come here. So here it is X. X we need how much? 12. Spacing we need 1 mm. Right we need. Clear? Here you write pin number A1. A1. Increment by 1. Here you make 0. Okay. And then click on origin. Now see. 12 pad came. Right?
Yes.
Again, here you give B2. B2. Sorry. Oops. Okay. Something is wrong, guys. Okay, let's see later. Oops. Here, C.
C1.
Oh, oops. B1 actually. B1. Guys, 1 minute. Something I'm facing problem. Just 1 minute. 1 minute down. Okay, B2, C1, D1, then E1, then F1. I think F1 will be not there. F or I will be not there. F I will be not there. F1, G is there. G1, G1, H, F, G, H, H1. Guys, don't go blindly. If you see here, something will be missing here. You see A, B, C, D, E, F, G is there. Here H, after that I is missing. Okay, so what they have given here, same you have to give. Okay, so here H, then J. Here J1,
J11.
then JKLM.
So we gave J11.
J11, huh? Oops. J1, then K1, then
L1.
L1, then
M1.
M1. See guys, these are pad placement done, right? You see this. If you give collapse itself, suppose we are taking here data sheet. If you do not give the collapse one, what will happen?
One pad to another pad, it will be short.
Correct. No. Something wrong, guys. Here pad stack itself given here 0.4 mm. We have done 8 mm, right? Okay, so that's why it is coming so close. Okay, no need to worry. Nothing is to worry. We'll get one more pad. So 0.4. Open calculator. So 0.4 is the pad stack of ours. We have done wrong pad stack taken. Okay. So take here 0.4. Okay. Percent 80. Oh. 0.4 into 80%. Wait. 0.4 into 80 divided by 100. So guys, 81 coming in 0.32, right?
Yes, sir.
So here our pad size will be 0.32, 0.32, right? Solder mask 0.32 plus 1.5. How much?
47.
0.47. Okay. Paste mask
0.32.
0.32. Okay, but guys, if you see 0.3 and 0.3 mm and 0.47 mm means just half it is becoming, right? Guys, here solder masking, if you see just half of this can't be possible actually. Okay, so here you give as the same 0.3, here also give 0.32 mm because it will become like double. Okay, file, saved. So guys, here you made mistake to place the this pad stacks. So again I have to delete all, right?
Replace. We can replace. No?
Guys, we have to delete. No, what the options we can apply there?
Replace.
Correct.
Replace.
Yes, replace. So in one set we can replace all. Go to your tool, pad stack, replace, then come to your options, choose old. Which one I want to replace? This one I want to replace. With which one? By C what? 32, right? Nothing is there. Huh? What the name given here? Oh, C30. Save as C32. Tools, pad stack, replace, browse your pads, this, then new will come, go, and what is the pad stack name? Just now we have done C32. This has come, click OK, and click here replace. Right click and done. Now see, all pad has been done here. Correct?
Sir.
Guys, clear this is?
Yes, sir.
Okay. So this is the pad stacks we have to use for the BGA. Right? Now, next is we have to move the origin to the center. Right? Guys, clear no?
Yes, sir.
So,
Yes, sir.
1, 2, 3, 4, 5, better than we just measure it from here to here. Here to here, how much? 11 mm. 11 divided by 2, 5.5, right? And here also 11 mm, 5.5, right?
Yes, sir.
Guys, the center will be IX 5.5, IY minus 5.5 because this is the same center, right? So X space 0 space 0, go to set drawing origin, come again, IX 5.5 minus 5.5. Now see origin and the center. Clear? Next we have to draw the outlines assembly. What assembly will telling? Here 12.8 by 12.8. D 12.8 by 12.8. Right? Go add line, same procedure what we have done earlier. Package geometry, assembly top, font 1016. Come to the command prompt, X space 0 space 0. Okay.
EX 12.
Then IX 12.8.
EX, sir.
Something wrong. Add line. X space 0 space 0. IX 12.8. IY 12.8. IX minus 12.8. X space 0 space 0. Clear? Guys, as of now, if you know our grid is 1 mm. To just place, I have kept the grid 1 mm. Now we can reduce to other processes, right? So go here, setup. Again, DN parameters. Here grid you can change 0.1 mm. Just to keep the pins as a precise manner, precise locations, we have done the things here. Now, this I want to move. So why it is moving at my mouse pointer?
You have to keep
Because-
body center.
Yes, because I have to take a move, then find, check here lines, options, choose here body center. Take this X space 0 space 0. Guys, clear? So you are feeling like here so much empty and here so much closed. No, it's not like that. Why? Because here texts are near, so you can able to see. Here texts are not near, so you can feeling like something like different. How to justify you are doing or not? You see, take here measurement tool, all of pins, lines. Take this, take this. How much it is? dy 0.9, right? Come here also. Take this, dy 0.9, right? Don't feel like you're so close, you're so far. No. Here all are the same only. Your text is upside. So you are feeling here so close outline, here so far outline. Guys, is that clear?
Yes, sir.
Pankaj clear? Bhagya clear? Okay. Next is if you see the pin number 1 chamfer, how to give. So go to your tools, chamfer, options, give here 0.5 mm. Take this chamfer, it will show the pin number 1, right? Again, circle, active class package geometry, subclass assembly top, here line with 0.1016, here give 1 dot to show the pin number 1. Okay, done. Now, since this is the BGA, we have to show so many things, right? So go again here, add text, write here A, here 1. Okay, then you will come to know which is A1. This you can bring here. Okay, so again add text, assembly and all here 2, 3, sorry, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here B, C, D, E, F, G, H, J, K, L, M. Now just take move and arrange it at the proper locations.